Welcome to Brain Vision.
In this question, we are taught to write the electron configuration of some elements using the core electron for the noble gas in brackets. The first one is phosphorus. So here is phosphorus, and like we know, phosphorus is in group 5 and period 3. So the noble gas before phosphorus is neon. So that means phosphorus is going to have a neon core. So if you put neon in brackets, and phosphorus is the 15th element on the periodic table. So its atomic number is 15. So neon is 10. So that means we'll have 5 electrons to fill. So because phosphorus is in the group 5, group 5 will have 3s2 orbiter and 3p3. So this is the electron configuration of phosphorus. Then the next one is germanium. Germanium is the 32th element. So its atomic number is 32, and the noble gas immediately before germanium is argon. So germanium is in group 4, so we're gonna have a 4s2 core, because we have the 3d orbital after or before germanium. Then the 3d, then because the role for the transition element ended with zinc, and the configuration for zinc is 4s2 3d10 with argon core. Then we can think about adding the s and the p orbiter, which case is going to be left with 4p to be added. So that is going to be 4p2, because the germanium is the second element in the p block of the 4th row. So that's going to be 4p2. Then the next one is zirconium. Zirconium is the 40th element, atomic number of 40. And the noble gas before it is krypton. And it will have a 5s orbiter, because the strontium will have a 5s2, right? And then we'll be left with 3d. We'll be left with 4d, and zirconium is the second transition element, so it's going to be 4d2. The next one here is iodine. And iodine is the 53rd element, and that means the atomic number is 53. So atomic number of 53. The noble gas before it is also krypton, and iodine has transition elements in between heat, before heat, so that's going to be 5s2, and the 4d10 orbiter will be filled as well. But the iodine is in the p block, so being on the p block is going to have a 5s and 5p orbiter. So we already filled the 5s orbiter, then we'll be left with a 5p orbiter. How many electrons should be in the 5p orbiter? So we can determine that by looking at the group number to which iodine fall. Iodine fall in group 7. So this the group 7 orbiter, they have the s and the p orbiter, with the s orbiter having 2 electrons and the p orbiter having 5 electrons. So here we already fill the s orbiter with 2 electrons, and then out of 7, if we have used 2, we should be left with 5. And this is the electron configuration of this element.